When you solve two-step equations, you're going to basically do the same thing as one-step equations, except there's two steps. So we have to know the order in which to do those steps. And so we're going to review the order of operations, because what we need to do to solve two steps, we do order of operations backwards, because it's like we're working backwards, sorting things on both sides of the equal sign until we can get back to having x alone. All right, so this is just a simple evaluation problem, and by order of operations, the first step we do is we multiply. So we get 2 times 4 is 8, and then we add and get 8 plus 3 is 11. All right, so it says now we know the above expression equals 11. So what if we didn't know what to multiply 2 by, then add 8 and get 11? Okay, so we're going to go backwards, and we're going to use our do-undo chart that I showed you with one-step equations. And over here, little note, when solving two-step equations, we must undo the order of operations in reverse order in order to get x alone. All right, so we're going to draw a line like we did with one-step equations. And if this was a one-step equation and that was just x, the first thing we would do is subtract 3 from both sides. Well, now we've got a 2x there. And in order of operations, or when we go to check this and find out what x is equal, we would have to plug in our value for x that we get for x. Well, it's 4. So we're going to just pretend like that is 4 right now. And instead of, we don't multiply yet, we're going to actually, or undo the multiplication, we're going to undo the addition first so that we can figure out what we've multiplied 2 by to get. Let's see. Well, if I subtract 3 from both sides, that would be what I multiplied 2 by to get 8, because this will be 8 over here. Bring down my equal sign, and 3 plus negative 3 is 0. And 2x plus 0 means I'll get 2x alone. So I'm working on getting x alone. Now, if I divide both sides by 2, it's like a one-step equation, and I will find out when I divide by 2, I get 1x, or x alone, and on the other side, 8 divided by 2 is 4. Now, I forgot to do the do-undo, but what do we do first in order of operations? We would multiply by 2, and then we would add the 3, because we multiply before we add. Whoops, I'm sorry, add the 3. Whoops. So to undo, you do the order of operations backwards, so I would subtract the 3, and then I would divide by 2, which is what I did here. Subtract 3, and then get 2x alone, then divide by 2, and get x alone. So x is 4. So now we're going to check it and make sure. So we're going to say 2 times 4, which we think is x, plus 3. Does that equal 11? So order of operations says, I say 8 plus 3, and 8 plus 3 is 11. So yes, it checks. All right, so our next one, order of operations. What we would do if we knew what x was is we would divide by 3, and then we would subtract 5. So we undo, we go order of operations backwards and do the opposite operation. So we add 5 and multiply by 3 when we solve. Okay, so first thing is I'm going to add 5, and remember this is like a negative 5. So add 5 to negative 5 and add 5 to 12 to keep it balanced. So now I have 17 on the right, and I have x over 3. You don't have to do this every time. I'm just repeating it just to get you used to it. X over 3 plus 0 equals x over 3. Then we're dividing by 3, so we'll multiply by 3. Or you can think of this as multiplying x times 1/3, and the reciprocal is 3 over 1, because this is like multiplicative inverses. And the product of multiplicative inverses is 1. and then 1 times x is x, and x is 17. So now to check it, we come over here and we say x. What am I saying? X is 17. We didn't multiply by 3 over there. Sorry, it's 51. Sorry about that. Got to keep it balanced, don't we? All right, so over here we've got x, which is going to be 51 divided by 3 plus 5. We're going to say, is that equal to 12? So order of operations, we do 51 divided by 13, which is 17, plus 5, which is 12. So it checks. All right, 2 more examples, and you can do practice. Okay, so the next example, let's look at what we're doing to x. We're multiplying it by -3, and then we're subtracting 15, my bad. So we order of operations backwards, we're going to add 15, and then we are going to divide by -3. All right, so let's draw our line. And we're going to start with adding 15. And remember, that's really -15. So we're going to add 15 to -15. That gives us 0, and -3x plus 0 is just -3x, or the additive identity. And then 3 plus 15 is 18. Then we're going to divide both sides by -3, which is the same thing as multiplying by -1/3, the reciprocal of -3. And that will give us, those are multiplicative inverses, that will give us 1 and 1x. Multiplicative identity is x alone. And over, oops, I forgot my plus -15. No, I already got rid of that. What am I doing? Oh, sorry. Divide by -3 over here, and I get -6. So to check it, is 3 equal to -3 times -6 plus -15, or we'll say -15, since that was the original problem. So -3 times 3, or 6 is 18, positive. Minus 15 is 3, so that checks. All right, last example. And remember, you can always rewind if you think you missed something. You can go back and check it. So order of operations, the do, undo. Now, this is really, I'm going to rewrite it, 5 plus -x equals 2. And I'm doing that for a reason. Okay, so remember the coefficient on the x, if there's nothing there, is a 1. So the first thing we would do to x, if we knew what x was, is we would multiply by -1. And I would have never known that if I hadn't made that adding the opposite and then put that 1 there. So be careful on that. And then we've got a +5. Now we're adding, and what a lot of kids do is they say, well, you're subtracting 5. No, you were subtracting x, and now you're adding the -x. So we're adding 5 to that. If that had been a -5, we would have had to put adding -5 or really subtracting 5. But it's not a negative, it's a positive. I'll go ahead and put the plus out there. Okay, so then the undo, we would subtract 5, and then we would divide by -1. All right, so over here, and you know, if you're going by the additive inverses to get 0, you don't really need to worry about the do undo, but I'm going to go ahead and do that just in case you like it better. So we're going to subtract 5 from both sides, and 5 and -5 is 0, and 0 plus -1x is -1x equals, and 2 and -5 would be -3. Then we're going to divide both sides by -1. That's a -1, not a 7. Okay, so -1 divided by -1 is 1x, and 1 times x is x alone. That's what we were trying to do. -3 divided by -2, or -1, is +3. So let's see if that's correct. Let's check. So we're going to say 5 minus 3, does that equal 2? Well, that's really easy to see. Yes, it does. So it checks. But a lot of kids get messed up on this problem because they think you're subtracting 5 from x. And so they add 5 to both sides and think x is alone. When it's not, that's a -x. All right, have a good day.